combine the type 1 and type 2 factor. Now let's remember what type 2 was. Type 2 was if you see a perfect square minus a perfect square, that's our bell ringer. We just break them apart. Now type 1 doesn't go away. Whenever you factor anything, from now on I say factor this problem, your first question you're always going to ask is there a greatest common factor? If there is, sometimes the answer to that question is no, by the way, but if there is, you factor it out and then you look at what's left. So let's look at this guy here. 3x squared minus 27. Greatest common factor? What do you think? What's the greatest common factor? Here and here. 3. And what gets left in here after we factor out the 3? Well, what about this guy?
Oh, 1. Or just x squared.
3 times what is 3x squared? 3 times x squared. 3 times what is minus 27?
Negative 9.
Oh, that ringing started again. Oh my goodness. Anybody else getting the ringing in the head? All right, we got the bells ringing. So, what's going to happen here? Can I further factor? What can I do? Go ahead.
Divide 3 and minus 9.
Well, let's see. Let's see how this works. Now, first of all, the 3 stays.
Oh, yeah.
The 3 that we factored out doesn't go anywhere. He is a factor of this, so he stays. Then I look at this, and I notice that it's a difference of squares, my bell ringer. I take the square root of x squared. What's the square root of x squared? X. So that's going to go here. What's the square root of 9? Plus minus, or minus plus, either way. And work backwards. Isn't that x squared minus 9? Isn't that 3x squared minus 27? So we should multiply back and make sure we did it correctly. All right, let's look at this next one. 4x squared minus 16. Do I have a greatest common factor? Yes. What is it? 4. Tell me what I got left here.
4 x squared minus 4.
Those ringing in my head. How about you?
Yeah, you would.
Yeah. So what should I do? Because I want to make it stop.
4 and then x plus 4.
Careful. Yeah, there we go. Excellent. And then work backwards. Now let's say you made that mistake and put the 4s here. When you check it to go backward, you would get a 16. You would find it on your check. So, I mean, we all make mistakes, especially me. All right, 8x squared minus 50. Is there a greatest common factor? Yes, what is it? What? 2. All right, what's left inside here? What? 4x squared minus 25. Oh, there goes that excessive ringing again. Oh, what's it going to be? Take the square root of 4x squared, that's 2x. Square root of 25 is 5, plus and minus. Remember that this thing you factored out here is still here because it has to work. And if you multiply all this back, you should get back up here, which we will. Any questions? That's not so bad. All right. We're going to work on these few tries. Some of them will have a greatest common factor, some of them won't. But you always ask the question. Looking at this one, is there a greatest common factor?
No.
So is there a bell ringing? I sure hope so.
Oh, yeah.
Okay. So go ahead, work these guys out. This is type 3. And with type 3, we're looking for a leading coefficient of 1. And everything else is x squared plus bx plus c, where these are numbers. So it could be x squared plus 5x plus 6. That's an example of this type of polynomial that we will factor with type 3. And the way these work is you say, we're kind of undoing the FOIL method. We're saying, well, gee, to get here, I had to multiply 2 numbers. But if you think about what FOIL is, you had to kind of do the outsides and the insides, and then those were added. So what we're basically doing is we're saying, what 2 numbers do you multiply to get this number, but add to get that number? And I kind of have this little device I use here. I put the number we multiplied, which is the C, that last number on top. And the number we're adding to, the B, goes in the bottom. And I say, gee, can we see it now? What 2 numbers multiply to 6, but add to 5? You see that? 3 and 2. Does it work? 3 times 2 equals 6, and 3 plus 2 equals 5? How'd you get that?
Well, I just knew that 3 times 2 would be 6 and then I
That's exactly what you did. Now, if you're having trouble with these, you're basically going to think of what are the factors of 6. Well, what are the factors of 6? Well, 1 and 6, those are factors, right? 1 times 6. Do they add to 5? No, so that's not it. 2 times 3. They do subtract, but they don't add. 2 times 3, well, that one works. So what your brain did was it was just kind of going through the different factors and seeing if they also added to the number we wanted. So let's look at one like this. So what two numbers multiply to 4, but also add to 4? Yeah?
2 and 2.
2 and 2. And you could be doing the same kind of idea, like very quickly, 1 and 4, does that work? No, it doesn't add to 4. 2 and 2, yes, that works. So your brain is kind of quickly running through that idea. How about I want two numbers that multiply to 12, but add to 7. Two numbers multiply to 12, but add to 7. What do you think? 4 and 3. Well, let's see, does that work? 4 times 3 is 12. 4 plus 3 is 7. Fantastic. And if you did it the kind of organized way, 1 times 12, is that 8 to 7? No. 2 times 6, is that 8 to 7? Not quite. 3 times 4, that one works. So your brain is kind of running through those possibilities, and if your brain isn't running through them, write them out. Make them run through it. What two numbers multiply to 9 but add to 6? What do you say?
3 and 3.
3 and 3. 3 times 3 is 9. 3 plus 3 is 6. Okay, so we got a bunch more here. Just going to do a few more. Two numbers, they add to 18, multiply to 18, but add to 9. Anything? 3 and 6. 6 times 3, 6 plus 3. Two numbers multiply to 24, that's 14. 12 and 2. 12 times 2, 12 plus 2. So your mind is running through all those factors. Two numbers, they multiply to 30, but they add to 13. Yes? 3 and 10. That works. Some of you guys are really going to be fast. Some of you are going to take a little longer. That's okay. It's okay. Now, what about subtraction? Oh, negatives. Now, let's think carefully. I'm going to multiply this number, right? To get a negative, what must be true of the numbers I'm multiplying? One's positive, one's negative. So, when I add them together to get here, they're different signs. It's a logical subtraction, isn't it?
Yeah.
And the signs are different. So I'm basically looking for two factors of 24 that subtract to 5. What do you think? Let's see, is it 1 and 24? Do they subtract to 5? 2 and 12? No, it's 10. 3 and 8?
Yeah.
Yes! Alright, now I have to figure out who's positive, who's negative. Result here is negative 5.
3 is positive and 8 is negative.
So 3 is 5, 8
Yeah,
is negative.
yeah.
Now, I will tell you right now, are you going to mix these up sometimes? Yes. So check it. Just add. Negative 8 plus 3 is negative 5. So that you don't mess that up. And then let's try another one. Negative 15 is where I want to get to. So one has to be positive, one has to be negative. Factors of 15 that subtract to 14. Yes. 15 and 1. Now who's going to be positive, who's going to be negative? Let's see, we're not sure, right? Let's try it. Oh, that works. Yeah. And if you do it wrong, you just find it like, oops, just switch it around. Now this one's kind of interesting. I've got a positive number here, but a negative number down there. How do I get that to happen? What do I know about the signs? Signs have to be have to be the same, and they have to be negative. It's the only way to add to that negative number here. So what two numbers multiply to 28? Add to 11. Over here. Yes. Go ahead. Oh, negative 7. There we go. Negative times negative gives us a positive. Negative plus negative, we get the negative 11. Okay, so the 2 minutes I have left. How you factor? Back to the page here. This is how you do it. First thing you do, draw those two empty parentheses that are going to hold your factors. You just kind of draw them. And then you put an X in the front of both of them. Why do I put an X in front of both of them? Why? Yeah, because that's how else can I get to X squared What's a multiply of x times an x? Just remember, I go backwards, I get there. Now we play our game. I want two numbers that multiply to this, but add to that. Two numbers multiply to 2, but add to 3. Yeah.
2 and 1.
2 and 1. These are positive numbers, right? Yeah. Couldn't be any easier, could it? Here they are. Plus 2. Plus 1. Stick them in there. And those are your factors. Verify, multiply back. Combine your like terms. Did I get the same thing I started with?
Yeah.
No fuss, no muss. That's how you do it. No fuss, no muss.
Yeah. I did.
Yeah. I'm trying to do them real quickly here. X squared plus 5x plus 6. You draw your empty parentheses, you put the x and the x in. Two numbers multiply to 6, add to 5. We kind of did this one already. 2 and 3. Plus 2 plus 3. Done. X squared plus 3x plus 2x is plus 5x plus 6. Easy peasy. Real quick, let's do this one. X. Two numbers multiply to 8, but add to negative 6. Negative 4, negative 2. Stick them in. Is this going to take a while to get used to it? But you will. And that really is a nutshell. Questions?